Massive stones placed with impossible precision stand all around us. These ancient construction mysteries reveal a world where our ancestors achieved what our best software and machines still struggle to replicate. By the end of this, you will understand the 20 most baffling architectural feats that defy modern explanation. How did cultures without wheels move 100-ton blocks? And why do their joints remain tighter than anything we can build today? What does it truly mean to leave a mark on the world that lasts for millennia? These stones of Puma Punku are not merely heavy, they are impossibly precise. Each block is a masterpiece of geometry, with edges so sharp and surfaces so flat they seem to have been sliced by a diamond saw. The andesite rock they used is incredibly hard, a material that would quickly dull modern steel tools, yet here it is carved with intricate channels and perfect right angles that interlock with neighboring stones. It is the complexity of these joints that truly baffles researchers. They used a unique H-shaped clamp system, carved directly from the same stone, that fit together with a kind of seamless accuracy we would struggle to replicate even with computer-controlled machinery. The question is not just about brute force, but about finesse. How do you achieve such a clean, machined finish without any of the power tools or advanced metallurgy we take for granted? The conventional explanation of laborers pecking away for years with stone hammers simply does not account for the microscopic level of perfection left behind. This points to a sophisticated and now lost understanding of stone itself. It is as if the builders possessed a fundamental secret, a way to work with rock that bypassed the need for harder tools altogether. This first mystery sets a daunting standard for everything that follows, forcing us to reconsider the very definition of ancient technology. This same quest for impossible precision appears again, thousands of miles away, in the staggering walls of Sacsayhuamán. Perched high above the old Inca capital of Cusco, these fortifications are built from limestone boulders so colossal they seem more like a work of giants than of humans. Some of these stones are estimated to weigh 200 tons, a mass that would challenge our most powerful cranes today, yet their sheer size is not the primary mystery. It is the way they are joined together. The Incas mastered a technique called polygonal masonry, which means each stone has a unique, irregular shape with multiple sides and angles. Through a method lost to us, they shaped these behemoths to fit against their neighbors with a seam so flawless that even a razor blade cannot find a gap to slip through. Think of trying to assemble a massive, three-dimensional jigsaw puzzle where every single piece is made of solid rock and weighs as much as a space shuttle rocket booster. The conventional theory suggests workers used harder stones to patiently pound and abrade the blocks into shape. This would have been a monumental undertaking, requiring not just immense labor, but an almost intuitive grasp of geometry. How could a builder without detailed blueprints or precision instruments look at a raw boulder and visualize the exact complex form needed to lock it perfectly into a growing wall? The result is a structure of incredible resilience. These walls have endured severe earthquakes that have toppled modern buildings all around them. While the ground shakes, the polygonal stones in the wall of Sacsayhuamán simply shift and settle, then lock back into place once the trembling stops, a dynamic system that mortar and rigid steel frames cannot hope to match. This was not merely stacking rocks, it was a profound conversation with the landscape itself, creating a bond between stones so perfect that it needed no glue and defies the relentless passage of time. This same principle of a perfect fit echoes within the very heart of Egypt. The Great Pyramid of Giza, stripped of its gleaming white casing stones, reveals its core structure, and here the mystery only deepens. We are presented with a paradox of immense scale and impossible exactness. Over 2 million limestone blocks, each one averaging 2.5 tons, were stacked to a height of 480 feet. But the true marvel is not the weight, it is the wafer-thin joints between them. In many places, the gap between these colossal blocks is less than a millimeter, thinner than the edge of a coin. How do you achieve such a consistent, hairline precision across a structure the size of a mountain? The conventional image of thousands of workers hauling stones up massive earthen ramps explains the movement, perhaps, but it fails to account for the microscopic accuracy of the placement. Maintaining such perfect alignment from the broad base to the soaring peak, all while ensuring the pyramid's sides were oriented to the cardinal directions with a deviation of just a fraction of a degree, suggests a guiding intelligence far beyond simple brute force. This precision culminates in the internal chambers, spaces that feel almost otherworldly. The king's chamber is built from monolithic beams of red granite, a stone far harder than limestone. Each of these beams was quarried in Aswan, over 500 miles away, and weighs an estimated 50 tons. The logistical feat of transporting these titans up the Nile and then raising them to the very center of the pyramid is staggering enough. But then you must consider the craftsmanship. These granite slabs were cut and finished with a smoothness that speaks of a masterful, repeatable technique. This was not random construction. It was a calculated endeavor rooted in a profound understanding of the world. The builders possessed a sophisticated knowledge of mathematics and astronomy that allowed them to create a structure that has withstood millennia. Modern buildings, with all our steel and concrete, struggle to last centuries. The pyramid's longevity forces us to look closer, to question not just how they moved the stone, but how they understood it. This same obsession with a perfect bond leads us to a truly global puzzle, one forged in metal. From the sun-bleached temples of ancient Greece to the high-altitude sites of the pre-Columbian Americas, we find the same mysterious solution used to lock giant stones together: metal clamps. At the legendary Temple of Jupiter in Baalbek, Lebanon, these clamps secured some of the most colossal stones ever handled by human hands. The logic seems sound. Metal bands would hold the massive blocks in place against earthquakes and shifting ground. But the mystery is not in the why, it is in the how. How were these metal pieces made and fitted with such incredible care? In many South American sites, the clamps were not simply poured as molten metal into a pre-carved channel. Instead, they were individually fashioned in a separate location, then carefully transported and set into perfectly shaped recesses carved into the granite or andesite. Think about the challenge this represents. You must first carve a complex, three-dimensional negative space into an impossibly hard rock with absolute accuracy. Then, in a distant workshop, you must forge a metal piece that is its perfect mirror image, a piece that will drop into that stone socket without a millimeter of wiggle room. This is not a simple blacksmith's job. It hints at a standardized, almost industrial process. It suggests a centralized knowledge of metallurgy that we do not typically attribute to these cultures. The puzzle becomes even deeper when we analyze the metal itself. In some cases, these clamps are made from alloys that our own historical timelines say should not have existed for another 1,000 years. They were using sophisticated metal recipes that modern industry has only recently begun to understand and replicate. This points to a lost science, a forgotten chapter in human innovation where the secrets of working with both stone and metal were held to a standard that still gives us pause. It forces a difficult question. If they possessed the knowledge to create such advanced metalwork, what other secrets did they hold that allowed them to move the very mountains these clamps were meant to bind? The challenge of moving mountains did not belong to the Egyptians alone. Far across the world, the Olmec people of ancient Mexico left behind a gallery of stone giants, colossal heads peering silently from the jungle floor. Each one is a single, monumental piece of basalt rock, some weighing as much as 20 tons. To stand before one is to feel the weight of a profound mystery, for the basalt quarries lay dozens of miles away, across a landscape of dense rainforest, swamps, and winding rivers. Without the wheel, without large animals to pull them, how did they transport these titans? The sheer logistics defy easy explanation. A common theory suggests a system of log rollers and sturdy rafts, a method that sounds simple in theory but becomes a monumental undertaking in practice. Imagine the scene: teams of workers maneuvering a 20-ton block of stone onto a wooden sledge, then carefully rolling it over shifting logs, all while navigating uneven, muddy ground. One misstep could mean the stone sinking into the soft earth or tipping over, destroying months of work. The journey would have required an entire community, a level of coordination and project management that seems to rival the construction of a modern skyscraper. They were not just moving rock, they were delivering a sacred object, a portrait of a ruler that needed to arrive intact. This was an operation of breathtaking skill and patience, a testament to a society that could organize and execute a plan with a precision we still struggle to fully comprehend. The silent, stoic faces of these heads are a memorial to that lost knowledge, a puzzle of transportation that makes the sheer scale of their achievement even more impressive. And if moving a 20-ton head seems impossible, the next mystery involves a stone so large it makes these giants look small. But the ancient challenge of moving mountains did not end with the Olmecs. Centuries later, in an era of powdered wigs and Enlightenment philosophy, a feat of pure physical power unfolded that rivals any from the distant past. The story of the Thunderstone is a monumental puzzle from the 1770s, a time when we supposedly knew everything about physics and engineering. The pedestal for the famous bronze horseman statue in St. Petersburg is not a composite structure. It is a single, staggering piece of granite. This rock was pulled from a swamp and weighs an estimated 1,250 tons. To put that into perspective, it is heavier than 10 fully loaded blue whales. The man tasked with this impossibility, Marinos Carberis, had to move this titan for several months across the Russian landscape using nothing but human strength and simple machines. His ingenious system relied on a track made of wood and a bed of bronze balls. Workers would lever the stone forward. It would roll minutely on these metal spheres, and then the track behind it was picked up and placed in front again. It was a slow, rhythmic dance of leverage and logistics, a testament to an almost forgotten principle that with enough coordinated effort, even the earth itself can be made to move. We have cranes and trucks today that can lift incredible weights, but they require paved roads, massive fuel supplies, and a huge financial cost. The movement of the Thunderstone was achieved with a profound understanding of friction, balance, and mass mobilization. It forces us to listen more carefully to the silent stones of older cultures. If a team in the 1700s could do this with bronze balls and sheer will, what does that suggest about the capabilities of ancient societies who had millennia to perfect their own methods? The successful journey of this stone is a powerful bridge, connecting the intuitive genius of the ancient world with the calculated engineering of the modern age, reminding us that some secrets are not lost, merely waiting to be remembered. Deep beneath the modern island of Malta lies a world carved not for the living, but designed to resonate with the voices of those long past. The Hypogeum of Sacsayhuamán is an underground labyrinth of halls and chambers, all meticulously hollowed from solid limestone over 4,000 years ago. Within this sacred space, one room stands out for its auditory magic, the Oracle Room. Here, sound does not simply travel, it transforms. A low-pitched male voice, when spoken into the chamber, does not fade away. Instead, it amplifies into a deep, resonant vibration that seems to pulse through the very stone under your feet and fill the entire subterranean complex. This was not an accidental feature of the rock, it was a deliberate creation. The Neolithic builders sculpted the curved walls and arched ceilings with a specific purpose, shaping the limestone to catch certain sound frequencies and magnify them in a way that feels both awe-inspiring and deeply spiritual. Modern acoustic engineers, with the aid of computer simulations and synthetic materials, work to achieve similar effects in concert halls. Yet here, in a chamber carved with stone tools, that perfect resonance was achieved millennia ago. How could a culture without a written language, without the physics of wave propagation as we understand it, possess such a nuanced mastery of architectural acoustics? This was far more than excavation. It was a project of sonic engineering where spiritual practice and scientific principle were one and the same. The mystery challenges our entire timeline of technological progress. It suggests that these ancient people did not just hear sound, they understood how to build with it, using the earth itself as an instrument to create experiences that connected the community to something greater. This profound link between sound, stone, and the stars reveals that their genius was not confined to what we can see, but extended into the very vibrations we feel, a harmony of science and spirit that modern technology can measure but still cannot fully explain. 5,000 years ago, a community in Ireland decided to capture the sunrise itself. The passage tomb of Newgrange is not merely a memorial site, it is a meticulously engineered timepiece made of earth and stone. On the morning of the winter solstice, the shortest day of the year, something remarkable happens. A single, narrow beam of sunlight pierces the pre-dawn darkness, traveling straight down a long, narrow passageway to flood the central chamber with golden light for precisely 17 minutes. This is not a happy accident of construction. It is the result of a feature known as a roof box, a small, perfectly positioned opening above the main entrance that acts like a celestial keyhole. The alignment required to make this happen is staggering. The builders needed to understand the sun's slow dance across the horizon throughout the year, pinpointing its most southerly rising point with an accuracy that would have demanded generations of patient observation. They then translated this celestial knowledge into a massive, permanent structure, ensuring that this brief moment of illumination would be reborn year after year. The engineering extends beyond this light show. The entire mound is a masterpiece of practical design, built with alternating layers of stone and earth that have kept the inner chambers completely dry for over 50 centuries. This longevity is a testament to their profound understanding of their materials and the environment. Modern software can simulate the solstice alignment, and GPS can map it with millimeter precision, but we cannot replicate the cultural synthesis that Newgrange represents. It was a functional calendar, a spiritual sanctuary, and a durable memorial all in one. This was a science woven into the fabric of daily life and belief, a harmony of cosmic cycles and earthly craftsmanship that challenges our modern separation of astronomy from architecture and of science from spirit. High on a lonely butte in Chaco Canyon, a spiral carved into the rock face waits for its annual moment of illumination. This is the Sun Dagger, a celestial clock built by the ancestral Pueblones over 1,000 years ago. Its mechanism is deceptively simple: 3 massive sandstone slabs positioned with impossible care that channel the sunlight into sharp blades. On the summer solstice, a single dagger of light slices directly through the center of the spiral. At the winter solstice, 2 perfect shafts of light bracket it, During the equinox, a spear of light bisects the carving with an accuracy that feels almost mathematical. This was not just art, it was a sophisticated calendar etched in stone and light, a way to mark the turning of the seasons with breathtaking precision. The true mystery lies in the placement of those slabs. Each one weighs many tons, and they were maneuvered onto a steep, precarious cliff face. The builders did not simply drop them into place, they adjusted them with microscopic subtlety, tilting and turning them until they cast shadows with the exact shape and trajectory required. The entire system is so delicate that when the slabs were accidentally shifted by researchers in the 1980s, the alignment was disrupted, a testament to the fragile balance the original engineers achieved. We can now model this event with satellite imagery and advanced software, but they did it with their eyes, their hands, and a deep, generational knowledge of the sun's path across their specific sky. This represents a different kind of engineering, one that works in harmony with the landscape rather than dominating it. It was a collaboration with the sun itself, a way of weaving time into the very rock of the canyon. This mastery of celestial alignment to mark time was not unique to the Americas, however, and our next mystery takes us to a windswept plain where an even grander stone calendar was built to capture the cosmos. The sheer scale of the stones at Baalbek defies belief. The Roman temple of Jupiter stands upon a foundation that includes the trilithon, 3 limestone blocks, each weighing close to 800 tons. But this is not even the full story. Just a quarter-mile away in the ancient quarry rests the stone of the pregnant woman, a single block of rock estimated to weigh 1,000 tons. To put that into perspective, that is the mass of 2 fully loaded Boeing 747 jetliners. The Romans were masters of engineering, famous for their cranes and pulleys, yet the movement of these particular stones pushes the accepted limits of their technology to a breaking point. Quarrying such a monolith is one thing, but how do you lift it and how do you transport it? The conventional explanation involves wooden rollers, levers, and the coordinated labor of thousands. Yet even with these methods, moving a 1,000-ton block across uneven ground presents problems that modern physics struggles to solve without steel rails and powered winches. The ground pressure would be immense, likely causing any wooden track to splinter and sink into the earth. The precision of the cut stones is another layer to the mystery. The trilithon blocks are not just massive, they are finished with clean, sharp edges and fitted together with seams so tight they challenge our understanding of Roman stone saws and drills. This was not merely a display of power, it was an exhibition of a lost logistical art. The site forces a difficult question. Did the Romans possess a forgotten method for managing such impossible weights, a technique involving counterweights, water flotation, or a form of social organization so efficient it could choreograph the movement of mountains? This puzzle of terrestrial mass logically leads our search for answers into a different element, to a place where the challenges of construction are magnified by the relentless pressure of the sea. Beneath the clear, blue waters off the coast of Japan lies a puzzle that challenges the very foundations of our historical timeline. The Yonaguni Monument is a sprawling complex of massive sandstone terraces, descending into the deep like a sunken citadel. What you see are not random rock formations, but structures that appear to have been deliberately shaped. There are what look like wide, flat platforms, perfect staircases with sharp 90-degree angles, and even a distinct 5-meter-wide triangular pool that seems too symmetrical to be the work of chance alone. If these features are indeed human-made, the implications are staggering. For this structure to have been built on dry land, it would have been constructed over 10,000 years ago, a time when our history books tell us humans were simple hunter-gatherers without pottery, let alone the capability for large-scale stone construction. The sheer amount of stone that would have had to be precisely removed from the bedrock to create these geometric forms suggests a society with advanced tools and a coordinated vision we do not attribute to that era. The debate between natural and human creation is fierce. Geologists point to the area's strong currents and the natural fracturing patterns of sandstone, which can indeed produce flat surfaces and sharp edges over millennia. Yet, how does natural erosion account for a structure that looks so deliberately architectural, with what appear to be carved pillars and connected passageways? The mystery forces us to hold two opposing ideas in our minds at once. Is this a breathtaking example of how nature can mimic human design, or is it the submerged evidence of a lost chapter in human history, a civilization that mastered stone on a grand scale only to be swallowed by the rising seas? Modern technology can map every inch of the monument with sonar and take samples of the stone, but it cannot tell us the intent of the builders, if builders there were. This underwater enigma pushes the boundaries of assembly into the realm of the seemingly impossible, suggesting that the story of ancient construction is far from complete, and that some of its greatest chapters may still be hidden beneath the waves, waiting for the tide of our understanding to finally turn. Behind the grand temple of Seti I, a different kind of mystery lies partially submerged in the sand. The Osireion is built from colossal red granite blocks, some approaching 100 tons, all fitted together with a stark, imposing precision that feels out of place. Its architectural style is strangely archaic, a stark contrast to the more refined stonework of the temple that stands before it. This has led many researchers to suggest a startling possibility that the Osireion is not a contemporary construction, but a relic from a far older time, a pre-existing monument that a later pharaoh simply incorporated into his own sacred complex. The granite itself tells a story of immense effort, quarried in Aswan over 400 miles to the south. Transporting these titans up the Nile was a feat in itself, but the real puzzle is in their assembly. The stones are interlocked in a way that directly echoes the mysterious Valley Temple at Giza, with joints so tight they seem to have grown together. The structure features massive, channel-like formations and a grand, sunken hall, all crafted from this incredibly hard stone. What was its purpose? Theories range from a symbolic tomb to a ceremonial center for rituals tied to the cycles of water and rebirth. But the why is almost as elusive as the how. The builders chose one of the most difficult stones available, investing unbelievable labor for a result focused on absolute permanence. Modern engineering can certainly cut and place granite, but we do so with diamond-tipped saws and hydraulic cranes. The Osireion represents a different philosophy, one where the symbolic power of the material and the quest for eternity were as important as the structure itself. This was not just building, it was a statement carved in the most durable stone they could find, a whisper from a past so deep that its methods and its meaning continue to hold their secrets tight. The silence of Egyptian stone holds the faint, persistent echo of a machine. Within the deep galleries of the Serapeum of Saqqara, one particular artifact tells a story that challenges our entire understanding of ancient workshops. It is a granite core drilled from a massive stone box, and its surface is marked by a continuous, spiraling groove. To a modern engineer, this groove speaks a familiar language. It indicates a drill bit that was fed into the impossibly hard rock with a consistent, unvarying pressure, removing material at a steady rate. This is not the jagged, irregular mark left by a laborer twisting a copper tube with sand. This is the signature of a process that required immense, stable force and a cutting mechanism far more efficient than anything we have found in the archaeological record. The granite used here ranks high on the Mohs scale of hardness, a material that would have shredded the soft copper tools typically attributed to the Egyptians. Some researchers studying the feed rate and the groove pattern have concluded that such a clean, precise cut would almost require a diamond-tipped tool or an abrasive slurry with a hardness we do not associate with that era. The mystery is not just the tool itself, but the power behind it. How was such consistent rotational force and downward pressure achieved, perhaps with a weighted, bow-driven apparatus that functioned with the repetitive accuracy of a modern drill press? This evidence of advanced mechanical knowledge becomes even more apparent when we examine the finished products. The massive granite sarcophagi found in royal tombs are monuments in their own right. Their surfaces are often covered in saw marks, but these are not random scratches. They are perfectly parallel, evenly spaced lines that cover vast areas, indicating the use of a saw that moved back and forth in a straight, unwavering path. To achieve this on a stone as hard as granite suggests a blade that was not just copper, but one that was embedded with jewel-like abrasives, or perhaps a continuous loop of cutting material, a concept that feels centuries ahead of its time. These marks point to a standardized, repeatable process, the hallmark of a sophisticated workshop technology. We have found their simple copper chisels and stone hammers, tools perfectly suited for soft limestone. But the evidence left on the hardest stones they used tells a different story altogether, one of a lost industrial art for hard stone manipulation. This silent testament of the saw and the drill forces us to ask where this advanced knowledge was housed and why the tools themselves seem to have vanished from history, leaving only their perfect, inexplicable marks behind. While modern engineering often builds upward, the creators of Petra's Treasury worked in reverse, carving a masterpiece from the sky down. This breathtaking facade was not assembled block by block, but revealed by removing everything that was not part of the final vision. Imagine the confidence required to begin at the very top of a towering cliff face, high above the desert floor, and start carving delicate floral patterns and statues of gods. Each strike of the hammer and chisel was permanent, an irreversible act of creation. The soft, rose-red sandstone was forgiving in one sense, but its very nature demanded absolute precision, as a single misplaced blow could shatter a column or deface a deity's face beyond repair. This was subtractive manufacturing on a colossal scale, a process where the architecture was not built but discovered within the mountain itself. The logistics are staggering to consider. Workers would have been suspended on complex scaffolding, their view of the emerging structure constantly shifting as they meticulously carved their way downward. Every day, tons of rubble had to be carefully lowered and cleared away, all while the grand design slowly emerged from the living rock. Modern construction relies on additive methods, assembling prefabricated pieces with the safety net of revision, but the builders of Petra had no such luxury. Their work was a high-stakes performance with no rehearsals, a testament to a planning process so thorough that it could visualize the final, perfect form before a single piece of stone was ever removed. This seamless fusion of art and engineering, of removing mass to create beauty, stands as a unique achievement that our own additive world struggles to conceptually replicate, pushing us to consider the very substance from which ancient wonders were formed. The relentless sea has spent 2,000 years trying to reclaim the harbor of Caesarea Maritima, and it has utterly failed. While modern concrete seawalls, built with our advanced knowledge of chemistry, often crumble into the waves after just 50 years, these Roman structures stand as strong as the day they were laid. Their secret was not in superior force, but in a smarter recipe. Roman engineers mixed their concrete with a special volcanic ash called pozzolana and lime, creating a material that did something our own simply cannot. Instead of being weakened by seawater, it grows stronger. When salt water seeps into the Roman mixture, it triggers a slow, ongoing chemical reaction. Over centuries, this process forms tiny, interlocking crystalline structures within the concrete, a mineral known as aluminous tobamorite. These microscopic fibers act like a permanent, self-healing reinforcement, locking the entire mass together more tightly with every passing year. The profound irony is that the Romans achieved this through generations of observation and practical trial, with no concept of molecules or nanotechnology. They simply found a formula that worked brilliantly. Modern science, with its electron microscopes, has only just begun to decode the full complexity of this ancient chemical dance. This discovery forces a humbling realization about our own industrial methods. Our ubiquitous Portland cement, the basis for most modern construction, is not only less durable but also far less kind to the environment, its production releasing vast amounts of carbon into the atmosphere. The Roman concrete, in stark contrast, was a sustainable solution, a material designed to last for millennia with a much smaller ecological footprint. We are now spending millions in labs trying to reverse engineer and replicate what they perfected through simple, patient innovation. This ancient mastery of material science presents a quiet challenge to our modern assumptions of progress, suggesting that some of the most advanced and sustainable technologies are not always ahead of us, but sometimes lie far behind, waiting in the silent, enduring strength of a 2,000-year-old wall. High on the windswept hills of Scotland, the remains of ancient forts hold a secret written in fire. Their massive stone ramparts are not merely blackened, but fused into a strange, glassy substance, as if the very rock had melted and flowed before solidifying again. This is vitrification, a process that demands a sustained, blistering heat of over 1,100 degrees Celsius, a temperature that would challenge a modern industrial furnace. To achieve this in the open air, across vast, uneven walls of granite and other stones, seems almost alchemical. Was this a deliberate act of fortification, a way to create a super-strong, fused shell that would repel invaders? Or is it the scar left by a single, unimaginable conflagration that engulfed these strongholds? The debate burns as hot as the original event. Experiments to recreate the phenomenon have consistently fallen short. It is not enough to simply throw more wood on the fire. You must maintain that extreme temperature evenly across the entire surface for hours, a feat of pyrotechnical control that eludes modern attempts. The logistics are baffling, requiring a constant, roaring inferno fed by an entire forest of timber, all while somehow directing the heat to fuse the stone without causing the entire structure to collapse into a pile of rubble. Whether by design or disaster, the result is a permanent transformation, a merging of stone into a new, crystalline material that stands as a monument to a forgotten mastery of fire. This mystery of intense heat leads us to consider its opposite, a challenge not of fusion but of perfect gravity-defying balance. Gravity seems to lose its meaning at the hanging temple of Hengshan. Suspended high on a vertical cliff face, this wooden structure has clung to the rock for over 1,500 years, a delicate dance of architecture that defies the most basic rule of construction, the need for solid ground. Its support comes from a network of oak crossbeams, each one slotted into holes painstakingly chiseled directly into the cliff. This was not a fight against the mountain, but a profound collaboration with it. The builders used the living rock as their foundational anchor, creating a system where the temple's weight is not just held, but intelligently distributed through a blend of leverage and flexibility. The oak beams were not rigid posts, they were chosen for their ability to flex and sway, to absorb the immense stresses of wind and the earth's tremors. When an earthquake strikes, the entire structure is designed to move with the cliff, a synchronized dance that prevents the catastrophic rigidity that can shatter a building on solid ground. Modern engineers can analyze this design and understand the physics of its force distribution, but to actually build it would be an entirely different challenge. It would require an intimate, almost intuitive knowledge of the specific cliff's geology and the unique properties of the timber, combined with a level of risk that contemporary safety codes would never allow. This was an intuitive grasp of mechanics, a wisdom built directly into the beams and brackets, where the line between the natural world and human creation beautifully blurred. This same principle of harmonious, integrated design finds its ultimate expression not on a cliffside, but in the sprawling, planned cities of the ancient world. This same principle of intelligent design for a functioning community emerges from the very dust of the Indus Valley. The ancient city of Mohenjo-Daro was a marvel of practical foresight, a metropolis built not for kings or gods, but for the everyday health of its people. Imagine a city from 4,500 years ago where nearly every single house contained its own bathing area and a dedicated wastewater outlet. This was not a luxury reserved for the elite. It was a standard feature of urban life, something many modern cities still struggle to provide universally. The entire settlement was engineered around a complex network of covered drains that ran beneath the streets, channeling waste away from homes and public spaces with an efficiency that would not be seen again for thousands of years. The centerpiece of this hydraulic mastery was the Great Bath, a large, waterproofed pool at the city's heart. Its builders did not simply stack bricks. They used a thick layer of natural bitumen, a tar-like substance, to create a seamless seal. This attention to detail reveals a profound understanding of material science and its application to public works. But the genius of Mohenjo-Daro extended far beyond its plumbing. The entire city was raised on massive, man-made platforms of mud brick, a deliberate defense against the seasonal floods of the mighty Indus River. This was urban planning on a colossal scale, a preemptive solution to an environmental challenge that many modern coastal cities grapple with today. Perhaps most telling is the evidence of standardization. Bricks throughout the vast city were manufactured to a consistent ratio, their dimensions uniform from one neighborhood to the next. This suggests a remarkable level of social organization and technical consensus, a shared blueprint for construction that allowed for efficient, large-scale building projects. The builders possessed a holistic vision where public health, flood control, and architectural uniformity were all interconnected. Modern civil engineering can analyze and appreciate the physics of their drains and platforms, but the true mystery lies in the societal mind that conceived of such a complete, functional system for communal well-being so early in human history. This was a civilization that had solved the puzzle of urban living, creating a harmonious environment that balanced human needs with the forces of nature, a feat that directs our gaze from the earthly plane toward the stars, to cities aligned not with rivers but with the cosmos themselves. The silent grid of Teotihuacan stretches across the Mexican highlands, a testament to a vision that transcended any single ruler. Its central artery, the Avenue of the Dead, runs for miles with an unwavering purpose, its orientation not merely practical but celestial, aligned to a precise point on the western horizon. This was more than a street, it was a terrestrial reflection of a cosmic order. The city's great pyramids rise from this grid not as random monuments, but as carefully placed anchors in a vast, sacred diagram. The Pyramid of the Sun itself was constructed from millions of individually made adobe bricks, a communal undertaking of staggering scale. Yet the mystery deepens when we consider its proportions. The volume of the pyramid, the ratios between its tiers, and its relationship to the surrounding mountains all seem to encode mathematical constants and cosmological principles that modern researchers are still working to fully decipher. How do you coordinate such a project across generations without a written language that we have been able to find, and without the centralized command of a king whose name we know? The answer appears to lie in a shared belief system, a common understanding of the universe so powerful that it guided every aspect of construction for centuries. Every new building, every plaza, every canal conformed to this original master plan, creating an urban harmony that feels almost impossible to achieve today. We can use satellites and global positioning systems to lay out a modern city with perfect geometric precision, but we cannot replicate the profound spiritual and social consensus that held Teotihuacan together. This was not just city planning, it was the physical manifestation of a worldview, a sacred geography where every citizen understood their place within a design that connected them directly to the heavens. This grand coordination of stone and space for a communal purpose leads us to the final, flowing mystery of ancient engineering, the challenge of moving water itself. The final mystery flows not from stone, but from the life-giving pulse of water itself. For 3,000 years, the Cant systems of Persia have turned barren landscapes into flourishing oases with a simple yet profound principle. They are underground canals that begin deep within a mountain aquifer where water naturally gathers. From there, a masterfully engineered tunnel slopes with a gentle, unwavering descent, allowing gravity to pull the water for dozens of miles to the surface, where it finally emerges to nourish farms and communities. The brilliance of this design lies in its hidden nature. By flowing underground, the water is protected from the relentless desert sun, preventing catastrophic loss to evaporation. This is sustainable engineering on a grand scale, a system that works in quiet harmony with the earth, recharging the very groundwater it draws from. The true marvel, however, lies in the creation of these tunnels. Without lasers or GPS, the ancient surveyors had to calculate a perfect, minuscule gradient. A slope too steep would cause erosion and destroy the tunnel, while a slope too shallow would halt the water's flow. They achieved this impossible precision using nothing more than simple sighting tools and an intimate knowledge of the land. Teams of workers then dug a line of vertical shafts down to the proposed tunnel level, some plunging over 100 feet into the earth. These shafts provided air, removed debris, and served as guides for the teams digging the horizontal canal from below. Imagine the coordination, digging in near darkness, ensuring every new meter of tunnel matched the exact level of the one before, all while relying on generations of accumulated wisdom passed from master to apprentice. Modern technology can map these ancient waterways from space, but it cannot replicate the deep, localized knowledge required to maintain them. A living tradition of hydro-engineering that viewed water not as a resource to be conquered, but as a partner to be guided. This brings us to a final, powerful reflection on all 20 mysteries. From the resonant chambers of Malta to the celestial clocks of Chaco Canyon, and now to these flowing tunnels of Persia, a common thread emerges. These were not just feats of isolated engineering. They were holistic arts where profound scientific insight was seamlessly woven into the cultural, spiritual, and environmental fabric of a society. The builders understood their materials, their landscape, and their cosmos with an intimacy we have since traded for raw power and speed. They did not seek to overwhelm nature with force, but to collaborate with it through finesse, creating legacies of stone and water that have endured for millennia, not in spite of time, but because of their timeless harmony with it. These patterns are not simply a list of impressive facts, but a key to a different way of thinking. Each of these 20 mysteries, from the fused stone forts of Scotland to the silent water channels of Persia, reveals a civilization that viewed the world as an integrated system. Their genius lay not in overcoming nature with brute force, but in listening to it, They understood the specific properties of the local limestone, the flow of groundwater, and the path of the sun, weaving this deep environmental knowledge directly into their architecture. This was a science of context where a building's purpose was inseparable from its place in the cosmos and its role in the community. The Great Pyramid is not just a tomb, it is a map of the stars. Newgrange is not just a memorial, it is a clock for the rebirth of the year. This integration of astronomy, spirituality, and pure engineering created structures that were functionally and symbolically complete, designed for both the immediate needs of the people and for eternity. The scale of their ambition was matched only by their patience. These were not projects for a single lifetime, but legacies that unfolded over centuries, requiring a social organization so cohesive that a master plan could be faithfully executed across countless generations. This long-term vision stands in stark contrast to our modern pace, where projects are measured in quarterly reports. They built for a future they would never see, guided by a shared belief system that provided a stable blueprint for 1,000 years. Modern technology gives us incredible power, but it often operates in isolated silos. An engineer designs the structure, an acoustician tunes the sound, and an environmental scientist mitigates the impact. The ancient builders had no such divisions. Their knowledge was holistic. The person who understood the mathematics of celestial alignment was the same person who understood the quarrying of stone and the management of a workforce. This unified intelligence allowed for solutions that were elegant, efficient, and breathtakingly durable. So the ultimate mystery may not be the how, but the why. What worldview, what cultural imperative drove them to achieve such perfection and invest such immense effort into projects meant to last for millennia? It challenges our very definition of progress, suggesting that the most advanced technology is not always about having the hardest tools, but about possessing the deepest understanding and using that wisdom to build in harmony with the world itself. These silent stones from across the ages speak a language of timeless ingenuity. We have stood before blocks that fit with impossible precision and walked through structures aligned with the cosmos, each one a profound challenge to our modern assumptions. These 20 ancient marvels are far more than relics. They are active puzzles that question the very definition of progress. They demonstrate a powerful truth that human creativity, when fused with patient observation and unified community effort, can achieve what we now view as impossible. The next time you walk past a modern building, consider the silent, enduring mysteries that have outlasted empires. These ancient sites were not built for a quick return, but as legacies meant to endure for millennia, a testament to a different kind of vision. If this journey into the unknown has sparked your curiosity, consider subscribing for more explorations into history's greatest puzzles. Let us know in the comments which of these mysteries you find most compelling and why. The past is not a closed book. It is an open invitation to listen, to learn, and to rediscover the lost languages of human achievement.